The concept of supermesh has been explained in the previous video. Before that, we have covered the mesh analysis as well. In this video, I will solve the numericals where the concept of supermesh is required. For that, let's consider the first problem where it is required to find out the current through 10 ohm resistor using mesh analysis in the given circuit. Now, what is the given circuit? Given circuit is having various resistances, one voltage source and one current source as well. The voltage source is of 2 volts, 1 ohm resistance, 10 ohm resistance, 5 ohm resistance, 15 ohm resistance, and current source is supplying 4 ampere current, and we are interested in finding out the current through this 10 ohm resistance using mesh analysis. So our first step is we need to identify that how many meshes are there. So clearly we have 3 meshes, first, second and third. Next step is we have to assign the mesh current. Let's assign I1 as mesh current to first mesh, I2 to second and I3 to third mesh. Now we have to apply KVL to each mesh. I will start with application of KVL to mesh 1. So when we apply KVL to each mesh, so what will we do? We will assign the voltage drop polarity as per the flow of current in that mesh. So this will be positive terminal, negative terminal of 1 ohm resistance for 10 ohm. This will be the positive terminal and this will be the negative terminal. Starting with 2 volt source, as negative sign is coming first, so -2, then drop across 1 ohm resistance, plus sign is coming first, so plus 1 into I1, then moving on to 10 ohm resistance. The voltage drop across 10 ohm resistance is 10 into resultant current through 10 ohm resistance in direction of I1. So as I1 and I2 are in opposite direction, so resultant current in direction of I1 is I1 minus I2. So it's plus 10 into I1 minus I2 equal to 0. So the simplified equation is 11 I1 minus 10 I2 equal to 2. This is our first equation. Now when we move to mesh 2, we have to again assign the polarity for voltage drop. Plus minus, I2 is flowing in our direction through 10 ohm resistance, so plus minus. We can write the voltage drop across 5 ohm resistance, we can write the voltage drop across 10 ohm resistance, but when we come across this 4 ampere source, we don't know that what is the voltage across this 4 ampere source. So what we conclude over here, that it's not possible to apply KVL to mesh 2, and same problem arises when we move on to mesh 3, because we have a current source in mesh 3 and we have a resistance. So let's mark the polarity of voltage drop across this resistance as well. Since a current source is common to mesh 2 and 3, so they are combined together to make a super mesh, and this will be the path of super mesh. So what we have, mesh 2 and mesh 3, they will give us a super mesh. So next step is apply KVL to Supermesh. Now when we apply KVL to Supermesh, so there is current through each resistance, is the current of respective mesh. For 5 ohm resistance it's I2, for 15 ohm resistance it's I3, and for 10 ohm resistance it's a resultant current in direction of I2. So starting from 5 ohm resistance, as positive sign is coming first, so 5 into I2 plus 15 into I3, that is the voltage drop across 15 ohm resistance. Then we move on to this 10 ohm resistance. Again positive sign is coming first, so plus 10 into I2 minus I1 equal to 0. So which will give us the equation minus 10 I1 plus 15 I2 plus 15 I3 equal to 0. This is the second equation. Third equation is according to the constraint imposed by this current source on this branch. Now current source is supplying 4 ampere current, so the current through this branch should remain 4 ampere and that should be in upward direction. So we want the resultant current in terms of mesh currents in upward direction. I3 is flowing upward, I2 is flowing downward, so the resultant current in upward direction is I3 minus I2 and it should be equal to 4. This is the third equation, which is actually a constraint equation. This is the third equation. Now we have 3 equations and 3 unknowns. These 3 equations can be solved simultaneously. So which will give us the value of I1 as minus 2.345 ampere, I2 minus 2.783 ampere, I3 1.217 ampere. So question was, we have to find out the current through 10 ohm resistance. Now the current through 10 ohm resistance is either I1 minus I2 or I2 minus I1. So it's I1 minus I2 means it's flowing in downward direction. Now using the value of I1 minus 2.345, I2 is 2.783, so the current is 0.438 amperes. This is the current through 10 ohm resistance. Let's consider one more problem to understand the concept of supermesh. The second problem is find the current in 3 ohm resistance using mesh analysis. Now the circuit for this is this is a circuit, 7 volt source, 1 ohm resistance, 2 ohm, 3 ohm, 1 ohm, 2 ohm, and this one is a current source of 7 amperes. So we need to check how many meshes are there. Clearly there are 3 meshes. We need to assign the current to each mesh. Let's say this is first mesh, current through this is I1. Second mesh, current through the second mesh is I2. This is third mesh, current through third mesh is I3. So when we apply KVL to mesh 1, we can write this 7 volt source. We can write the voltage across this 1 ohm resistance. Even we can write the voltage across this 2 ohm resistance, but the problem arises when we come across this 7 ampere source. Again, we don't have the knowledge about the voltage across the 7 ampere source. And same problem will be there when we try to apply KVL to mesh 3. So what we need to do in this case, we need to combine mesh 1 with mesh 3 to make a super mesh. Mesh 1 and mesh 3, they are combined together to make a super mesh. So mesh 1 along with mesh 3, they are combined together to make a super mesh, and then we have to apply KVL to super mesh. Now let's assign the voltage drop polarity according to the direction of current of I1 and I3. I had already marked for I1, let's mark it for I3 as well. Starting from the 7 volt source, minus 7 plus 1 into resultant current through this 1 ohm resistance in downward direction, that is I1 minus I2. The next resistance is 3 ohm resistance. The resultant current through this 3 ohm resistance is I3 minus I2, which is in same direction with I3, plus drop across this 1 ohm resistance plus 1 into I3. Now this is the path, we are coming back to this one, equal to 0. Now you need to keep this in mind that this 2 ohm resistance, it is in series with 7 ampere source. So we don't need to write the voltage across all the elements which are in series with the 7 ampere source, since we have just neglected this branch and combined mesh 1 and mesh 3 all together. So the rearrangement of this equation will give us I1 minus 4I2 plus 4I3 equal to 7. Now this is our first equation. Second is the constraint equation. Now that constraint is imposed by the 7 ampere source. The 7 ampere current source is supplying current in downward direction. So we want the mesh currents in downward direction. That is the resultant of mesh currents in downward direction. So that will be I1 minus I3 equal to 7. This is the second equation. Third equation we will get by applying KVL to mesh 3. So now when we apply KVL to mesh 3, we don't have any source over here, so I am moving it little upward. Starting from this 2 ohm resistance, 2 into I2 plus, now polarity of voltage drop across 3 ohm is like this, because we have to mark the polarity of voltage drop as per the direction of I2, and this one is lower terminal is positive for 1 ohm resistance and upper is negative for 1 ohm resistance as per the direction of current I2. So plus 3 into I2 minus I3 plus 1 into I2 minus I1 equal to 0. So when we rearrange the terms, the final equation is minus I1 plus 6I2 minus 3I3 equal to 0. This is our third equation. Now when these equations are solved simultaneously, I1 is 9 ampere, I2 is 2.5 ampere, I3 is 2 ampere. So our question was, we need to find out the current through 3 ohm resistance, this one. So it's either I2 minus I3 or I3 minus I2. As I2 is more, so I3 ohm is I2 minus I3, and this is the direction. So 0.5 ampere from, sorry, no, it's in just opposite direction, from right to left. I2 is more as compared to I3, so obviously the resultant current will be in same direction with the I2. Let's take one more example. For finding out the current through one of the resistance. Question is, find the current through 10 ohm resistance using mesh analysis. Now the circuit for this is 5 ohm resistance. Here we have a current source of 3 amperes, another current source over here, 10 amperes, 1 ohm, 10 ohm, 5 ohm, 50 volt. So the circuit is quite similar to the earlier one, but the difference is that the current, we have two current sources in this. In the previous circuit we had one current source, now in this we have two current sources. We have three meshes. Let's mark the mesh currents: I1, I2, I3. These are the three mesh currents. Now if we try to apply KVL to mesh 1, then we have a problem to write the voltage across 3 ampere source. When we try to apply KVL to mesh 2, what we see that we have a 3 ampere source as well as 10 ampere source in the circuit, so we can't write the voltage drop across these two as well. Then we have the problem for voltage drop across 10 ampere source again when we try to apply KVL to mesh 3. So now in this case what we need to do, we need to combine these three meshes all together to make super mesh, because we have a current source common between mesh 1 and 2, then between 2 and 3 as well. So we have to combine mesh 1, 2 and 3 to make super mesh. So we will have just one equation by applying KVL, and rest two equations will be according to the constraint. So next step is apply KVL to super mesh. Voltage drop polarity, this is across for 5 ohm resistance, this one is for 10 ohm resistance. Now starting with this 50 volt source, minus 50 plus 5 I1 plus 5 I2 plus 10 I3 equal to 0, and we can write this as I1 plus I2 plus 2 I3 equal to 10, first equation. Now we need to keep this in mind that we don't need to write the voltage drop across this 1 ohm resistance, since this 1 ohm is common between first and third mesh, and we had already combined mesh 1, 2 and 3 all together. So all the branches which are common to these meshes, they are actually neglected. We don't need to write the voltage drop across that circuit element. So 1 ohm is common to first and third mesh, so we don't need to write the voltage drop across this, because this is not coming in the path of supermesh. This is the path of supermesh, and 1 ohm is not part of the supermesh. Then we have constraint equations. Now we don't have single equation, we have multiple constraint equations, that is 2. First is the constraint imposed by this 3 ampere source, that the resultant current should be 3 amperes and it should be in downward direction. I1 is in downward direction, I2 is in upward direction. So constraint is I1 minus I2 equal to 3 amperes. This is the second equation. Second constraint is imposed by this 10 ampere source. Now as per this constraint, the resultant of mesh currents should be from right to left, and it has value of 10 amperes. I2 is in same direction, I3 is in opposite direction. So the second constraint equation is I2 minus I3 equal to 10. Now when we solve these three equations, I1 is 9.75 amperes, I2 is 6.75 amperes, I3 is minus 3.25 amperes. This one is coming out as negative. It means this is the polarity, the assigned polarity is just opposite to the actual polarity, or assigned direction of current is actually opposite to the real direction of flow of current. It means I3 is flowing in this direction and I10 ohm is 3.25 ampere and it's in upward direction. In next video, I will discuss more problems on mesh analysis, but in that case I will consider dependent sources as well, since the numericals which I had taken till now, whether it's the simple mesh analysis or the concept of super mesh, we had all independent sources only. So to understand that how to consider the dependent sources in the circuit, what will be the difference in writing the equations, or what is the difference when we have a dependent source in the circuit, that you can understand in the next video.